Hi, Jameson Tutorials. In this session, we focus on trigonometry, and the question is, show that sine theta plus sine 2 theta over 1 plus cos theta plus cos 2 theta is identical to tan theta. Roman 2, express 4 sine x minus 3 cos x in the form this, where alpha is acute and r is positive. Find all solutions of the equation this in the interval this, giving your answers to the nearest degree. B, find the greatest and least values of this. In particular, my interest is on this part here, how to arrive the answers very fast, the shortcut. Also the proof, that might also be interesting and you learn something from it. Okay, we start straight away with Roman 1. We'll copy the left hand side of the proof, which is sine theta plus sine 2 theta all over 1 plus cos theta plus cos 2 theta. So you notice that when you have a proof like this, you always normally, most of the time, start with the complicated side and simplify to arrive the simpler side. So that is what we are going to do here. Again, if you see any trig identity or any trig expression of this form, which is involved in a proof, and there is a double angle. So you have sine theta, then sine 2 theta, double. Cos theta, cos 2 theta, double. Sometimes you will have sine theta on 2 and then sine theta, is still double. Sine 2 theta and then sine 4 theta is double. So in those cases, bring in the double angle identities. If I have sine theta plus sine something that is not the double of theta, like 5 theta, I should be thinking of factor formulae to bring in when I'm doing the proof. So take note of those hints. So here we're going to use the double angle identity for sine 2 theta, which is 2 sine theta cos theta all over, wherever 1 and cos 2 theta appear. In such cases, you have to replace 1 with cos squared theta plus sine squared theta. That is one of the Pythagorean identities. So cos squared theta plus sine squared theta is always 1. Then I bring in my cos theta, and then the identity for cos 2 theta, which is cos squared theta minus sine squared theta. That will be identical to up. I factorize sine theta into. I now divide every term up by the common factor. So when I divide sine theta by sine theta, I get 1. When I divide the other term there, I get plus 2 cos theta all over. Down, you notice that sine squared minus sine squared will cancel, and cos squared plus cos squared will give you 2 cos squared theta plus the other term now, which is cos theta. That gives you sine theta into 1 plus 2 cos theta all over. Down again, cos theta is common, so I put cos theta into, I divide every term again by cos theta, I get 2 cos theta plus 1. The bracket up and down, they are the same, so they cancel, and then sine theta over cos theta is tan theta as required. Okay, in Roman 2, we are required to express 4 sine x minus 3 cos x in the form R-sine x minus alpha. That is what the question says. Express this in the form this, alpha is acute and r is positive. So this is the form we have. And then here now, I'm required to use the compound angle identity for sine A minus B If you don't know it, if you can't recall it, it is in the formula booklet. So you go there and get it. Don't try to guess, because if you guess wrongly, you would have messed up in the rest of the question right down to the end. So take note. So that identity provides that sine x cos alpha minus cos x sine alpha should replace sine x minus alpha. And then I expand the r. When I'm expanding, I just make sure cos alpha is closer to r for precautionary measures. So I get cos alpha and then sine x minus r sine alpha and then cos x. So that was just to make sure that you read the coefficients on the right hand side appropriately. You can still expand without bringing the alpha closer to r. But when I bring it closer to r, it now gives me the coefficient of sine x on this side, which corresponds to 4 there. And so I'll be talking of comparing coefficients. I would get on this side the coefficient of sine x is r cos alpha, which corresponds to 4, and there is negative r sine alpha, the coefficient of cos x, which corresponds to negative 3. So r sine alpha should be equal to 3. With these two, if I square both sides and add, cos squared plus sine squared gives me 1. So simply when you arrive here, just say r squared equals the sum of the squares of these two numbers, which should give you 4 squared plus 3 squared. Therefore, r would be the square root of all these gives 25, which gives 5. Again, as a warning, if you come and you're reading coefficients and there is a negative sign on the right hand side, any of the right hand sides there, know that you have not read the coefficients well, or you have used a wrong identity. You go back and check. Whatever sign appears in the middle here would always be the same sign here. You can never have minus here and plus here. It will never happen. So take note. Once it arrives there, check whether you have made a mistake if there is a negative sign in any of these numbers. Now to get alpha, I will simply divide these two equations in such a way that the sign is up and the cosine down. So I will divide this second equation by the first so that tan should come out. Don't divide the other way around. You will instead get caught, which might slow down your solving. Okay, so we get dividing. We have that tan alpha should be equal to 3 all over 4, and that implies that alpha will be the tan inverse of 3 over 4, and that gives 36.87 degrees. And so we can now conclude that 4 sine x minus 3 cos x is identical to r, which is 5, sine x minus the alpha, which is 36.87 degrees. So that answers the first part we have expressed in the form that they wanted. In the A part of the equation now, they want all solutions to the equation this. So once they have done that now, you would take this form and replace. It will now be easier for you to solve. You take this form and replace with this, and you'll be able now to solve. So in the A part, we would now talk of 4 sine x minus 3 cos x being equal to 3 as 5 sine x minus 36.87 degrees being equal to 3. So that sine x minus 36.87 should be equal to 3 all over 5. And we'll be needing the principal value of this angle. So we say PV of x minus 36.87 degrees should be sine inverse of 3 all over 5. And sine inverse of 3 all over 5 should be 36.87 degrees. Okay, after having the PV, remember, so we have to make use now of the general solution for trigonometric equations that involve the sine function by stating that x minus 36.87 degrees should be equal to, from the formula booklet, you can get that formula for the general solution, which involves -1 to the n of the PV, and my PV is 36.87 degrees plus 180 degrees n. And so x would be -1 to the n of 36.87 degrees plus 36.87 degrees plus 180 degrees n. We are required to find values of x within 0 to 360. So I will simply be substituting values of n in this expression and then getting the corresponding values of x. When n equals 0, n should be any integer. If I take -1, for example, I can't get an answer within the range. So we could begin directly with n equals 0. X would be -1 to the 0 would be 1, so 36.87 degrees plus 36.87 degrees plus n being 0 there will give 0. And so adding these two, we get 73.74, which they have said the answer should be to the nearest degree. That should give 74 degrees. When n equals 1, x would be, I substitute 1 again for n in the general solution. I should get -1 to the 1 remains negative, so this is -36.87 degrees plus 36.87 degrees plus 180 degrees into 1, and that simply gives 180 degrees. It's already a whole number, so it fixes things there. Then when I put n equals 2, this would already be 360 degrees. And -1 squared becomes positive, so 360 again will be, adding all these other ones will be out of range. And so this is the last one, because of course 3 can't give anything again within the range 2. So we conclude from here that x equals 74 degrees and 180 degrees as the only solutions within the range that is given. So in the B part, we are asked to find the greatest and least values of this expression. There are two ways of doing it. The first method I'm going to show you is the easiest, a shortcut which you can always use if you have to be sure of getting the answer correctly without mistakes. In that method, I simply make arguments that 1 all over 4 sine x minus 3 cos x plus 6 is greatest, that means maximum, when 4 sine x minus 3 cos x, this denominator, that is what determines what happens to this function as it's varying. So that's the variable part of the function, would be maximum, that is greatest, when this expression, which is equivalent to 5 sine x minus 36.87 would be minimum. So what determines this, actually what we have is this 5 sine x minus 36.87 plus 6. So this one is equivalent to this. Actually, we have to put it in this form to see what is happening. This expression, which is this one, would be maximum, would be greatest when this part at the denominator, which makes the function to be varying, is minimum. So for me to get a maximum value out of this function, this part that is varying should be at its barest minimum. And the minimum value is negative r. Remember, this is a stretch of the sine function here. And you stretch it vertically up to 5 and down to negative 5. So it's minimum at negative 5 and maximum at 5. And so when this expression is maximum, or this one, which is the same thing, it would occur when this part down is minimum. So this is greatest when 5 sine x minus 36.87 is minimum, i.e. negative 5. That is the minimum value of this function. It determines now the maximum for this. So if I substitute the barest minimum value of this function, this part of the function, which is negative 5, I will now get the maximum value. It follows that greatest value equals, I just put 1 all over the minimum part, which is negative 5 plus the 6, and that gives you 1 over 1, which is 1. The same argument will be used, the fact that 1 all over 5 sine x minus 36.87 plus 6 would be least. In the case of finding the least value now, is least or minimum when 5 sine bracket x minus 36.87 is maximum. This part again, when it is maximum, this denominator will be large, and dividing 1 over that now will give you but the least value of the expression. So that is the argument. So maximum here is r, which is 5 in this case. And so we now say least value would then be 1 all over the maximum value for this part, which is varying, plus 6, which gives you 1 all over 11. So this is the least value and this is the maximum value. The other method involves you starting with the fact that the expression first that we had, which was we start with sine x minus 36.87 lying between negative 1 and 1. That's what we know about the sine function. It lies between negative 1 and 1. If I have to work until I get this expression, I simply multiply it through by 5. That gives negative 5 less than equal 5 sine bracket x minus 36.87 less than equal 5. And in that expression, they have added 6. So I start building up by adding my 6 to, adding 6 on both sides. Negative 5 plus 6 will give me 1 less than equal 5 sine x minus 36.87 plus 6 less than equal, adding 6 to that 5 would give us 11. Now the expression is inverted, so I have to work until I get this whole expression that I'm looking for the least and greatest values in the middle of this, my inequality. So if I have to invert, remember when you invert 1 and 11, the inverse of 11 now becomes smaller than the inverse of 1. So to do the inverse, I simply exchange the extremes. So I'll now be talking of 1 all over 11 should be less than or equal to the inverse of that middle, which is 5 sine bracket x minus 36.87 less than or equal to the inverse of 1, which is 1. In this form now, sorry, there is plus 6 here. In this form now, whatever value is here is my minimum value of this expression in the middle, and whatever value is here is my maximum value of the expression in the middle. And you can see it's already what we're looking for, the minimum and maximum value. So the minimum value now would be 1 over 11, which corresponds to what we had there by just using arguments and concluding. And the maximum value again is 1, the same value we had up there by doing arguments and concluding. So take note, whatever method works for you, you should use, but I think this method is good. It's simple and shorter too.